Hello, yet another AQA Physics A-level question. If you want to try a different question, if you hit the information card up here, it'll take you to the playlist for the current electricity topic. Anyway, if you're going to do this question, pause the video now. If you got the answer A, well done. If you didn't, here's my explanation. So 3 identical cells, each with an EMF of 1.5 volts and an internal resistance of 6 ohms are connected to resistor R. The resistance of R is 6 ohms. So we've got three cells, each with an internal resistance of 6 ohms. So we can see this section here is like a parallel section, isn't it? So the first thing we ought to do is try and find the total resistance of those 3 internal resistances when they're in parallel. And we know that the 1 over the total resistance is equal to 1 over resistance 1 plus 1 over resistance 2, etc. So the total resistance of this section is going to be given by 1 over 6 ohms plus 1 over 6 ohms plus 1 over 6 ohms for our 3 internal resistances. Do a little bit of maths and you'll discover that the total resistance of this section is 2 ohms. Now, just to explain what's going on perhaps a bit more simply, a bit more easily, I'm going to redraw this diagram. I'm going to draw it with the part of the cell that produces the EMF. And we know that's producing an EMF of 1.5 volts. I'm going to put the internal resistance, or actually the equivalent internal resistances of these 3 resistances in parallel. And we've just discovered that's 2 ohms. And then I'm going to put this external resistor, this 6 ohm resistor, on the outside. So we know that current is equal to potential difference over total resistance. So the potential difference is the EMF in this case, 1.5 volts, and the total resistance is 6 plus 2 ohms is 8 ohms. Put that into my calculator and I'll get an answer of 0.19 amps. Answer A. If this was useful, hit that subscribe button, press the like button, share with your friends, but certainly please watch more of these videos. Thank you.